Hey folks, today's episode was sponsored by Datadog. It's a cloud-scale monitoring and analytics platform. Datadog was built to bring clarity to complex dynamic applications in the cloud, on-premises, in containers, or wherever they run. With beautiful dashboards, distributed tracing, and seamless integrations with more than 200 technologies, including Azure and Docker and PagerDuty, Datadog provides deep end-to-end visibility into the health and performance of modern apps. Visualize key metrics, set alerts to identify anomalies, and collaborate with your team to troubleshoot and fix issues fast. I'd like you to try it yourself by starting a free 14-day trial today. Listeners of this podcast will also get a free Datadog t-shirt. Get started at bit.ly.com/DatadogShirt. That's bit.ly.com/DatadogShirt. Hey, this is Scott Hansel, and this is another episode of Hansel Minutes. And today I'm talking with Matt Phillips from Big Evil Corporation. And how are you, sir?
I'm fine, thank you.
I am freaking thrilled to talk to you because, as folks know, I do a lot of retro gaming. I'm looking in my desk right here, and I see 4 different arcade machines. I have a Sega in the other room. I've got Nintendos and Super Nintendos, and you're doing something interesting. You have created a brand new and original game for the Sega Megadrive, or the Genesis, as people know it on the US, called Tanglewood, except you're releasing this on a cartridge. You had a successful Kickstarter, and you developed it in an interesting way. You didn't write this with modern tools.
Yeah, no, all written with development hardware using original processes and methodologies.
And being with original hardware, like an actual developer device from Sega.
Yeah, it's a cross products development kit who were the manufacturers of development hardware at the time, from 1992.
Oh my goodness. Okay, so what is that now? How old is that? 26 years?
Ish, yeah.
Ish. So my dad is a woodworker, and he has a whole woodworking setup in his garage, and he's got all these modern tools and modern devices and laser this and laser that to go and work with ancient techniques and stuff. And every once in a while he'll watch a show called the traditional woodworker or whatever, and he'll see them doing the old style wood and the old style stuff. And I'll say, "Why don't you do it like that, Dad?" And he's like, yeah, it's impressive to watch, but it's hard to do. So we'll use the modern tools. How did the onus of this, how did you decide to not just write this in modern tools with an emulator? Why do it with the original tools?
I guess it's an authenticity thing. Something I wanted to do since I was a kid. So the dream kind of never left me. So when I decided to finally do it and I got the opportunity to do it, I still wanted to do it like it was done when I was a kid. Just sort of try and live that dream properly, so to speak.
When you say with the opportunity, did you decide one day, or did something happen that presented it to you?
I've been trying to get into it for many years. I tried learning on an Amiga and an Atari at the time. I really couldn't get along with it very well. It was when I started working at Traveller's Tales about 8 years ago. Some of the old veteran Megadrive programmers there had got ideas into my head to say, you should really follow up in the stream. It's actually really easy to do. Just give it a go. Just try it again. And I did. And after that, I started scouring websites for this development hardware, trying to put pieces of the puzzle together, try and get it. And the thing came from all over the world. So it wasn't a day I woke up and said, right, I'm going to do this now. It was a couple of years of looking for the pieces for this equipment. Slowly getting more and more excited about the project as more and more pieces of it came in, and it was a slow brewing process over many years.
And just for context, for people who might not know what Traveller's Tales is, these are the folks that make the Lego games, as including other things, and we see that TT logo in all of our Lego games. So you worked there?
Yes, I used to.
And they've been around for forever as well. They started in 1989. So while we think of them maybe modern, today as like Lego Star Wars, that's an animation studio and a development company that's been around for 30 years.
Yeah, they started doing Amiga games. I think their first game was Leander back on the Amiga. They started doing Megadrive games after that, and they managed to acquire some large licenses, things like Sonic 3D, Toy Story. They did a Mickey Mouse game, and they went from there onto Lego.
So does that mean that you had like the help or the assistance of original developers? I don't know how old they are now, but folks that remember this stuff?
It was mostly the inspiration. They used to tell me stories about their time working on the Mega Drive, what it was like back then, what equipment they used. Nobody sat down and showed me the ropes, so to speak. They just gave me their stories, and it kept the stream alive.
Mm-hmm. So it was more inspiration. You didn't have a tutor. You sat down and how did you learn this? Did you learn this by reading 68,000 assembly language manuals?
It was mostly trial and error. I managed to do some very basic things like move some memory around, things like that, by reading some tutorials on things like Amigas. But most of it was just trial and error. I did manage to find some example source code in old archives from Sega themselves. It was quite a difficult thing to piece together. There are a lot of small demos out there showing you how to do small things like put Hello World on the screen and things like that. But actually putting it together into a big, fully fledged game with various levels and big backgrounds and stuff, it was very difficult to do. I had to learn most of that myself through trial and error, reverse engineering, things like that.
So this is a tough question, but maybe as software developers, we'll be able to answer it. Do you know if you did it right? Like, it looks amazing. Tanglewood looks amazing. People are calling it the new Shovel Knight. It's gorgeous. It's got scrolling in multiple directions. It's got multiple layers. It's got rich sprites. It's a gorgeous game. But do you know, like, given that you learned it from scratch kind of in a vacuum, that it was done in the way that they did it back then?
I believe so. Maybe my coding style might be a bit different because I grew up learning C and C++, and all my first work on games development was with modern tech. I published games for PlayStation 2, 3, and 4, Xbox 360, Xbox One, that sort of thing. And the languages and technology is very different now, and I learned on that. So I tried applying some constructs from modern programming back to assembly language to see if things like that would work. Things like off-screen culling and things like that, and how memory is managed. And some of it worked, some of it didn't. Some of it used too much memory, some of it used too many clock cycles, because obviously modern coding paradigms are very different. And we used to bigger processors, bigger memory. So I don't know is the honest answer to that question. I don't know if it was done exactly like it was back in the day. I know I used the correct tools. I know I used the correct language. I know I've used the correct processes, but I don't know about my coding style if it matches. If I can find some other examples, maybe I can tell.
I'm looking at a Mega Drive Hello World with scroll that you put up on Pastebin. And so this is a Hello World scrolling around, and it's just 466 lines with comments. It's a Hello World is not console.write line in this world. You have full control. I assume when you make a mistake, it just locks up hard and you turn it off and turn it on again?
Yep. Either that or it'll continue running as if everything's fine, but there'll be some subtle bug somewhere that you haven't seen. Those are the worst.
So that means you find out 30 seconds later or minutes later?
Minutes later, maybe right at the end of the game when you've nearly finished the final boss, you'll find a bug based on a thing that was written to memory an hour ago.
Oh no! Did that actually happen?
Yeah, that's happened quite a lot in my career. Not just on this console.
How in the world do you do that? I mean, today we have debuggers that can do snap points and memory shots and comparisons across time, and even step back debuggers. How in the world could you know that a butterfly flapped its wings and a sprite got corrupted an hour later?
I guess I got the advantage of the hardware being a lot more simple than modern devices. There's only 64 kilobyte of memory. I mean, if worse comes to the worst, I could view up the memory and I could scroll through all 64 kilobytes of it and have a look myself.
Good point.
There's tools the assembler dumps out to show you areas of memory that belong to which part. It can even give you the variable names and the labels in it too. So there's a lot you can do to try and figure out bugs like that. it's long and time consuming still, but I'm not completely alone there.
Okay. Now, I could probably do this by opening up Notepad and figuring out what 64K looks like. But I mean, if you printed out 64K and you were have you ever done that? Have you ever printed out all the pages of 64K of memory and stared at it on your living room floor?
Not physical printed. No, I've had it open on various screens,
mm-hmm.
but no. The only code I printed was back when I was starting, and I needed to take some time out and go and sit outside to try and figure out a problem because it was irritating me so much. I needed a change of scenery.
Mm-hmm. So you said I'm going to make a game, and you said I'm going to make a real, true to life 16-bit platforming experience. Where did you find the original Megadrive CD development kit? Because I think that requires another PC next to it that runs Windows 95. Is that correct?
Yeah, it doesn't have to run in Windows 95. It only needs MS-DOS for the debug to run. The only reason I'm even using Windows 95 is so I can have network connectivity to back up my work. That's one of the modern constructs I'm using is modern source control and backup systems. I'm not making that mistake ever again of not having those things around. So yeah, Windows 95 just for the networking part, so I can transfer files around. But most of the work is done in MS-DOS. The assembler and the debugger.
What limitations did you put on yourself, and which ones did you think were like unreasonable? Like you say that you did it in the original tools, on the original hardware, and the original PC and the original development kit, but did you allow yourself to Google?
Yes, I allow myself to Google. It was the only way I could really get started.
Okay.
The other big rule I allowed to slip was if I was going to write my own tools, things like level editor, things like that, I was going to do that on modern hardware. I'm using Visual Studio to write my own level editor, audio conversion tool, things like that on my modern PC.
Okay.
That's because C++ development tools back then were pretty awful, pretty horrendous. And I'd like to have written the tools fairly quickly using constructs I'm already used to. So yeah, I did write my own tools for the job. That was one of the rules I set myself, but I did use modern PCs to do that.
Okay, that seems like a reasonable compromise. So I understand that you created a level editor or a maps tile sheets system called Beehive?
Yes, I did.
And that's up on GitHub at github.com/bigevilcorporation. And that's been in development now for a couple of years. I can see that you had check-ins 2 years ago on that. So this is a long process.
A long, slow brewing tool, this. I edit it almost every day. I don't run it standalone anymore. I run it through Visual Studio because there's always something I need to add, something I need to change. It's a very fluid tool, that one.
I see. So this isn't something where you install it and run it from the start menu. It's something that you are constantly hitting F5 in VS and then saying, "Oop, I need this," and then you go and change it and hit F5 again.
Yeah, indeed. I guess one day it'll start to mature, and I can release a version 1 of it. Probably at the end of Tanglewood, once development's finished, I can say, yes, this tool now has everything I need to write a similar game.
Mm-hmm.
Let's just generate an executable and we're done with it.
So we can go up and look at your workshops at bigevilcorporation.co.uk, and you can see slides from a workshop you did on Sega Megadrive assembly. And within those slides, you talk about Hello World and what's involved, but then you jump into sprites and tiles and maps. Maybe you could explain the relationship between the code and where the resources live in the Sega world. Are these, forgive my dumb question, but bitmaps on disk somewhere, or are they assembly code as well?
They are assembly code as well. All the code and all the data is bunged into one binary. Well, I guess that's the same for MS-DOS games of the time as well.
Mm-hmm.
You could bung the whole thing into a single executable. There's no other files to speak of. It's all loaded in memory when the executable loads. There's a similar construct for ROMs on these kind of systems. All the code, all the data, all the audio is all bunged together in one single memory blob, and that's loaded from cartridge. It's quite difficult to manage something like that in assembly language itself. You have to arrange your code and your data to behave with each other.
Mm-hmm.
You have to worry about things like memory alignment. Distances between blobs of memory is tricky as well, because there are certain opcodes that can read data with from a short distance away from the code. There are some opcodes that can read data from all over the cartridge. So depending on particular optimization tricks you're learning, you have to arrange the data in a certain way as well. So yeah, it's been quite a tricky thing to learn that, but very rewarding.
Oh, wow. So did you have to write your own font? Like you had to put in, the alphabet and write and draw your font and then store that and then remember where it was, so that if you were putting a sprite up and then suddenly needed to put up some words, you had to think about where they were in relation to each other?
Yes, indeed. It's all stored as raw tiles in the ROM. So you'd have a label to the start of the font. There's no text drawing routines at all. You had to write all those yourself. The system doesn't have an operating system. It doesn't have any standard libraries. You're just alone with the processor and the memory. So you have to do all that yourself. You have to arrange the font tiles onto the map grid yourself manually when you want to draw a string.
Oh,
so yeah, there's quite a lot to think about.
The way that you said that, you're just alone with the processor. Like, it's been so long, I think, for a lot of us that are listening, who, there's no standard library. If you want to write a string length method, that's on you. If you need to draw a circle programmatically, do you even have a math processor or a way to do cosine? You probably can't do things like that.
Nope, it's integers only. 16-bit integers only. There are only some opcodes on the thing that can do 32-bit maths. You have 16-bit multiplication, division, 32-bit add, subtract, things like that. So you're limited with even the integer toolkit as well. So no floating point maths to speak of, unless you want to write your own software method, but it's just too slow to use that for general purpose.
Oh, my goodness. So how are maps done? If you have 64 hardware sprites and you've got maps, are you building maps with kind of Lego pieces of platforms and totem poles and trees?
It's split up into tiles. There's the sprite layer, which is used for things like characters and moving objects and stuff like that. But there's two background layers with their own individual maps. So you can have two scrolling play fields behind the sprites. And that's all split up into tiles, which are 8 by 8 pixels each. So the tool I've got, you can import bitmaps of large stamps, so big pieces of scenery, things like that. But once it exports, it splits the whole thing into tiles, 8 by 8 pixels, searches for duplicates to save memory, and then packs all into a binary blob for me.
Hey friends, a quick word from our sponsor. Progress Telerik wants to send someone to the Build Conference, so they're having a contest. Step 1 is to sign up to learn about the new, innovative, modern UI tools that they'll be announcing at Build. And by registering, you'll be entered to win a full conference pass to Microsoft Build, plus a $500 travel stipend. They're also giving away 3 Telerik DevCraft UI licenses. All you have to do is register at buildcontest.pwop, that's PWOP.me. That's buildcontest.pwop.me. Progress offers the leading platform for developing and deploying mission-critical business applications, and they are the creator of the award-winning Telerik.NET and Kendo UI JavaScript user interface controls. They have reporting solutions and productivity tools and all the tools that developers need to build high-performance modern apps with outstanding UI. Go now to buildcontest.pwop.me, that's PWOP.me, and sign up to win. One of the things about Tanglewood that is worth pointing out is that, the little fox, what is the fox? Does the fox have a name?
Nim.
So Nim, the fox, is running around in this tangled wood, and it's not a platformer like a Super Mario, where it's very perpendicular and there's horizontal stuff and there's vertical stuff. The trees are warped and tangled, and he's not walking just left and right. He's walking to the right, and then he'll move up a few pixels and then down a few pixels and up a few pixels. Did something simple like that, quote unquote simple like that, from a design perspective, I would anticipate would require a non-trivial amount of work to make it just feel like he's fluidly running over for lack of a better word, a Bezier curve of a tree branch.
Yeah, Bezier curves, right. That's how they're described in the editor. And then they get converted to tiles of their own. I follow the same process as the graphics tiles. There are individual collision tiles there, which are 8 by 8 pixels each. and those describe the terrain. I spent quite a lot of time on the physics engine and how all the train systems work and collision, things like that, and how they all work together.
Did people call them physics engines in the early 90s? Like, was that a thing that we knew of and had discovered, or is that a modern concept applied to older hardware?
I'm not entirely sure. There's only so many examples I could look at as well. If you remember the game Pugsy, that was another Traveller's Tales game. That had a physics system in it where you could pick up objects, you could throw them around, and they would bounce off each other, things like that. Object can be marked as buoyant to float in water, that sort of thing. The only other example I can think of, bear in mind I haven't played many games that are non-platformers, is the box pushing in Sonic, where you can push the little green block onto a button. But I think that's only used once in Sonic 1, which is a bit of a waste, really.
Yeah, that's funny. There's been times when you'll play a game and they'll introduce a concept, and then you'll never see it again. And you're like, wow, that was amazing. And they just kind of never used it. That sucks.
Yeah. It was in the second stage of Sonic 1, the little green block that you push on the button, and I don't think I ever saw it again.
Yeah.
It's really weird.
The physics really are interesting in Tanglewood, given that it's 26-year-old development system where, Nim will pick up one of the little yellow balls and roll it with him. So then you've got to think about him. You've got to think about something in his control, and they all need to work together. And when he throws it off of a ledge, it bounces. It moves realistically. So it's almost, like you say, modern techniques applied to older hardware.
Yeah, there's quite a lot going on behind the scenes. Arguably, it was one of the mistakes I made trying to bring this modern construct back to consoles like that. The optimization I've had to do to get that to work properly within the frame rate is absolutely ridiculous. Nearly every optimization session I do to try and make the game run faster has always been in the physics engine.
Really?
Yeah, there's a lot going on behind the scenes. There's acceleration, velocities, friction, restitution. There's specific bounce modes for certain objects. There's buoyancy, which I've had to take out now, unfortunately. There's various gravity modes. So if you're inside water, it'll half the gravity and half your movement velocity, so it feels like you're sludging through water. Mm-hmm. There's quite a lot going on, and that's on top of the collision for all those curves and all the terrain data. And as you say, objects interacting with each other. So yeah, if Nim pushes one of the little fuzzle balls, there's a tether system there where it's tethered to the player. It'll make sure that the bounding boxes never collide, and one pushes the other one out of the way. So yeah, there's quite a lot going on behind the scenes, and I'm not sure I'll do another game with a physics engine like this again. It's been an absolute nightmare, but very much worth it. I'm very happy with what I've achieved with it.
Not to take too much time to dwell on the negative, but you mentioned kind of casually there that you had to remove buoyancy. Is that because it is just technically too much for the processor to handle?
It is, yeah. I wanted the fuzzle to float, and other objects. There's things like crates in the game. There's balls that you push around, and they all needed different buoyancy values. And it meant trying to fix bugs where if there was a crate in the water and a fuzzle in the water, they have buoyancy applied. They're also colliding with each other. You've also got the other physics systems running, like the player terrain checks and stuff like that, and the whole thing just sort of fell over, really. My frame rate was really low. So I had to change the puzzles that included buoyancy and unfortunately remove them.
I've noticed that as you move through the game, the environment changes. There's different, I don't know the right word because I'm not a game developer, but different palettes. There's like dark and scary and blue and purple woods, and there's bright and happy and light green woods. Are you switching out sprites or palette shifting? How do you make it seem like it's a lot while being not a lot?
Yeah, it's an interpolation between palettes. It's not quite a palette shift or a palette swap. There are 3 palettes at play there. There's a daytime, a dusk, and a night palette for each stage of the game. And it fades slowly from one palette to the other as you move through the game. So it's sort of a linear interpolation between palettes.
The people are making these games and making Sega games now, and they usually release them as ROMs, and people can run them on an emulator. You can go up and go to Big Evil Corporation and go and Google for Tanglewood, and you can get a demo of a version of this, right? And I can play this on an emulator. But what you're doing is special because not only did you use an original Mega Drive development kit, you're going to the work of releasing an actual physical cartridge. Do they even make did you have to design the black cartridge bit, or where would you even find a Sega cartridge container anymore?
I had to send off some original Sega cartridges off to a toy shop in China to have them analyzed and 3D scanned. And they helped me design one that doesn't infringe on any patents or trademarks, but still works with the system. I sent them over files of my logos and things like that. So we've now got a nice cartridge that works in all systems, PAL, NTSC, and the Japanese ones with the locks, which has my logo on the back and fits standard PCBs. That took quite a while to sort out. There was a lot of back and forth, a lot of samples being sent, a lot of corrections made. And we finally had a mold machined to mass produce them.
Oh, wow. Because it has to look and feel and act like a cartridge. It needs to be able to plug into my Sega, but it also has to not be an exact copy.
Yeah, it can't have Sega's logo on it. So yeah, it's the correct size, the correct shape. It's even the correct weight. That was something I was adamant about.
Mm-hmm.
But with my logo on.
Will, this might be a silly question, but I've got a device that's an emulator, not a Sega proper, not an original Sega, but one of these multi-cart type situations. That is itself an emulator. If I plug this in, will it work? Will it download the ROM, or would it need to be updated to support Tanglewood?
No, the general rule is if your system plays Sonic 2, it'll play Tanglewood. There's no strange tricks or demo scene style techniques in there that might trip up certain older or poorly written emulators or clones or things like that. The idea was I wanted to play on people's original consoles,
mm-hmm.
But also things like their home arcade systems running Raspberry Pis or things like the Retron 5, which is a multi-cart clone system.
Right.
Compatibility was high on the list. So for this game, at least, I haven't used any odd tricks or anything that might trip up those particular systems.
How did you watch for that? Did you feel that, did you know, oh, this is a trick, everyone knows that's a trick? Or was it a matter of doing something and realizing it was a trick?
It was mostly already knowing that, what I'm doing here isn't quite standard. It's very timing dependent, or it uses a weird, lesser used 68K opcode or things like that.
Good point.
Or it abuses something that isn't documented. There was a demo scene group called Titan who released a demo called Overdrive 2, and they discovered a hidden debug register in the GPU, which allowed for operating it in various modes that were non-standard. And they figured out how to abuse it to make transparency with, which is something not seen on the Mega Drive. And that was absolutely fantastic. But they found it only worked on certain models of Mega Drives manufactured within certain time spans.
Oh my!
So yeah, that kind of thing, it fascinates me. It's fantastic. I read up a lot on that kind of stuff, but it's not something I'm going to put in my games because I want it to work with everybody's Mega Drive or emulator.
It does also make you wonder, like, what was going on at Sega that they would do that? Were they just brainstorming, or were there just why would you put a flag in there or a debug register and ship it and not tell anyone and keep it to yourself?
I think it was a mixture of unfinished features. I'm with a Discord group of Sega developers who have looked in detail at this GPU and figured out that Sega were trying to do more with it, which is probably why they had the Mega CD add-on later, which added a load of features like scaling and rotation. They believe that this stuff was originally meant to be in the Mega Drive, but they either ran out of die space or money or time or a mixture of all three, and they didn't make it. So I guess some of those features they started working on, and they're only accessible using debug registers. But obviously it was never finished, and it doesn't work very well.
Mm. And then you also had to find someone to do the printed circuit boards, the PCBs to put inside of the cartridges. and put it all together and then flash the ROM onto the cartridges in a way that you could actually sell it?
I approached a company called DB Electronics out in Canada. And it's not a flash technology we're still using original 5-volt EP ROMs, like would have been used back in the day, nice heavy things. So we've managed to find a cache of 1,000 of these in some warehouse out in China, and we're using all those up. Once we run out of those, we're going to have to think of something else, maybe go for a flash-based method for the next batch.
Yeesh. So you're using original cartridges that were discovered in a room somewhere?
Just the ROM chips that are on the PCBs. Chips. The PCBs themselves had to be designed.
So once you sell 1,000, then you have to figure out how to get past that.
Yeah. I have to think of someone else. There's
an interesting article on the DB Electronics Canadian website about the issues around using 5-volt systems and 3.3-volt flash and how you can hurt yourself.
Yeah, that topic comes up quite a lot every time I post a link to my games. The first comments always say, "Is this going to be 5-volt instead of 3.3 volts?" Yeah, yes, it is, for the 1,000th time. That article is certainly worth reading if you're into homebrew development or collecting and you like to use the original hardware. But I've been using 3.3 volt systems for development for nearly 3 or 4 years now, and I haven't seen any problems with any of my systems. So take it with a pinch of salt. It is a problem. He's proven it to be a problem, but we don't really know the long-term effects of using 3.3 volts. We don't really know what exactly is going to happen if you do carry on using these things, and how long it's going to take for problems to appear, or even where in the machine these problems are going to appear. We don't know. I'm using 5-volt chips just to be safe. It's not a risk I'm willing to take, seeing as this evidence has popped up that something might go wrong at some point in time, somewhere in the system, maybe. We don't know. The mass supports the problem, but I don't think in practice anybody has seen anything go wrong just yet.
So people can go to tanglewoodgame.com. They can download the demo, which is a version 0104 of kind of an alpha build, and they can try it out. And if they like it, they can click pre-order now, and they can pre-order this. What's the pricing like? And this actually comes with a cartridge and instructions, a manual. It's going to look and feel like you remember Sega Megadrive, and Genesis games were 25 years ago.
Yeah, it's currently 45 plus VAT, £45 GBP. Obviously, the more we make, the cheaper it's going to get. So maybe perhaps after release, we might be able to bring the price down. It's quite an expensive thing to do. It's been monumentally difficult, and there's a lot of people involved. The price is the subject of much discussion. But for now, that's what it's costing us. So.
Fortunately, we're not all 13-year-olds, though, now. I think if we're interested in this, we're no longer 13 trying to put that money together. In fact, we're supporting an entire burgeoning industry of retro gamers. And if we can make Tanglewood successful, then hopefully that will make the next Tanglewood successful that is maybe written by someone else.
Yeah, I'm hoping so. There's certainly other homebrew projects out there. There's one called Xenocrisis, which is a Smash TV-like game, and they were recently successful on Kickstarter too. So yeah, if you keep supporting things like this, we're only going to make more of them.
That's cool. So we can go out and search for that as well. They have a Kickstarter, Xenocrisis, very, very different game, and certainly something else that people could support. So I'm excited that I can use this on my Retron as well. So people can take a look at that at tanglewoodgame.com. Very cool. Well, thanks so much for chatting with me today, Matt Phillips from Big Evil Corporation.
Thank you very much.
This has been another episode of Hansel Minutes, and we'll see you again next week.